Okay, so now we're going to deal with algebraic expressions, and this is really where we're starting to set our toe into the field of algebra. Before it was pretty much arithmetic and computation. So with algebraic expressions, one of the defining characteristics of that are variables. And so by a variable, we mean a letter that represents a value. And then we have constants, and a constant is any real number. We're not going to deal with anything but real numbers. So we're not going to deal with imaginary or complex numbers, anything like that. It's only real numbers. And so a real number doesn't change in value, so we call it a constant. A variable, on the other hand, can be a number that we assign to it. If we want to recalculate something, we can assign it a different value. If we're looking for the value of a variable in an equation, there may be more than one value that makes that equation true. So a variable is just that. It is variable, but a constant doesn't change. So when we have an expression like this, and notice this is an expression, and I want to make the distinction between an expression and an equation. Here this is just a value that I'm throwing out there that's expressed as a combination between constants and variables. And so it doesn't have an equal sign. If we had an equal sign in there, equals 3 or equals 0 or something like that, that would be an equation. So this is an expression, not an equation. So we look at these things and break them up into what we call terms. And you can see this one has 3 terms. That last one, since it's just a -6, we call that a constant term. And so the terms are separated by addition. And so the negative sign that we have there, I mean, that looks like we're doing some subtraction, 3x minus 6. Really, we consider that from the standpoint of terms is that negative rides along with that 6. So if we change around the order of this expression, we can easily say -6 plus 2x squared plus 3x, and we have the same expression just reordered. So the number that precedes the variable we call coefficients. Oops. Yeah, I guess that was time to switch this slide. So when we have expressions, oftentimes we want to simplify them because we'll have some sort of model or so or something that we've collected, and we want to make the simplest possible expression. So here's an example of an expression that has 5 different terms in it, and what we're going to say is that we have like terms among 2 pairs. So what we're looking for with a like term is that the variable is exactly the same and the exponent is exactly the same. So in some expressions we might have more than one variable. So if we have an xy, that is a distinct term from anything that involves just x or just y. And so what we want to do with the like terms is we want to add or subtract the coefficients depending on their sign, and we can simplify this expression. So in this case we have the 2x cubed plus the x cubed, so we add 2 plus 1 is 3, so we got 3x cubed. Then we have -4x squared and -2x squared. Add the -4 and the -2 and we get -6. The x at the end is the only term like itself, so that just rides along, and so we have this simplification. Now, we're going to deal with different expressions, and you're going to be asked to simplify things, and sometimes you're going to be asked to factor things. And so the book is a little bit contradictory about is something factored, simplified, or the other way around. And that's kind of an open question. But simplification always involves collecting like terms. So if you are directed to simplify something, this is kind of the minimum you should do, is make sure that you only have one instance of every kind of term and combine them all together. Okay, so in order to simplify the expressions, we want to use all those properties of real numbers that we went over before to remove anything that's grouping them. So when we have, let's say a polynomial is what it's called, where we have the sum of several different terms, what we want to do is make sure that we remove the the parentheses and the brackets. And the strategy here is that we work from the innermost parentheses outwards. And so notice that there's a bracket and a parentheses. And a bracket and a parentheses in this context are exactly the same. You use them only because it's convenient and it's easy to see that that first bracket pairs with the very last bracket, and then the first parentheses pairs with the last parentheses. Sometimes when you have layers of parentheses, it's hard to keep track of, how many did you open and how many do you have to close. You can use the bracket and parentheses interchangeably, and in fact, you can change them or insert them if you want. They're exactly the same meaning mathematically. So in this, what we want to do is look for the innermost parentheses, and that's the parentheses that is surrounding that x minus 8. And so we ask ourselves, can we simplify that? And in this case, that is as simple as it gets. There's nothing we can do with that. So then what we do is we distribute that negative 4. So we have negative 4 times x, and negative 4 times negative 8 gives us positive 32. Now you may want to do this in your head when I'm all done with it. You may want to skip over this, this particular step, but I'm going to suggest you don't. And the reason why I say that is I would say that most algebra students at your level of algebra can probably gain 2 or 3% their overall grade if they can do this step reliably, where that last negative times negative becomes a positive. It's easy to understand. It's easy to do 99 out of 100 times. It's hard to do it 100 out of 100 times. So you can avoid, the mistakes that are just kind of the boneheaded mistakes that you'll see me make all semester by writing things out. And so the next level then is to collect the terms. We combine the terms. We have 2x minus 4x. And so we get negative 2x plus 32. And then we distribute that 3 and we get negative 6x plus 96. And so at this point we're done. All right, I do want to go back a little bit. Now, I used 4 different steps to get to that answer. Or actually, I took 3 steps, right? I had the problem, then I did the first thing, second thing, and third thing. I would really strongly recommend that you try and do it this way. Make it as neat as possible, right under, one line under another like this, and don't skip any steps. I would say probably most people can probably avoid doing 1 or 2 steps just in your head. Like if you go from the second to the 4th step, you think, okay, 2x minus 4x, and I got to multiply that by 3, so I'm going to get a negative 6x. That's mathematically sound reasoning, but what you miss is the ability to pick up your simple mistakes, the mistakes that that once you get a test back and you lose a point or 2 or 3, you slap yourself in the forehead saying, gosh, I know that. That's just a stupid mistake. That's like a typo or something. And like I said, you'll see me do it all semester. If you lay it out like this and you finish your problem, ask yourself one question. Did I get the signs right? And so you don't worry about that you multiplied 4 times 8 properly. Did you multiply negative 4 times negative 8 and get a positive 32? So just look through the signs. And I guarantee you, you'll get a it'll have a very positive impact on your scores, on your grade. You'll have a much better feeling for how you're doing. And you're not going to let the easy points go by. It's kind of like, if you're playing basketball and you miss a free throw, you feel bad about missing that. You don't feel bad about missing necessarily a shot that, is difficult, but a free throw you should make, right? And the same thing here, we should get our signs right. There may be math that's a little bit beyond us or a difficult problem or so, but get your signs right. And so lay it out. First thing to do is ask yourself that one question. Did I get my signs right? Now, I'll give the same advice when we're evaluating expressions. Okay, so we want to make parentheses our friends, all right? Parentheses is a way to avoid sign errors. And so with this example here, I want to evaluate 2x over x minus y when x equals negative 1 and y equals negative 2. Now, subtracting x minus y is not difficult. You can, most people feel like they can do it in their head. But I would suggest, when you're working, always take steps forward and never steps back. And so I would lay out this substitution like this, where I have my variable, I put a parentheses, and I just drop the value of that variable right inside the parentheses. And that's one thing that I'm doing, and I don't have to worry about how complicated the problem is. Can I solve it from there? Can I do anything else? You're not worried about that. You're doing one thing, just with a solid, sure footing, getting that value in where it belongs. And now you have a different sort of a problem and an easier problem, because you don't have to worry about substitution. All you have to worry about is now distributing your signs properly. And that 2 times -1 gives you -2. That -1 minus a -2 turns into -1 plus 2. So you get -2 over 1, which is -2. I have never seen it, never, ever, ever seen it where somebody works faster because they write less. When you write every part of your calculation, every part like this out, you will be working much faster than if you do it in your head. All right? Think about when the pencil's moving, that's free time. That's like when you're copying, let's say you're copying something over and you're not thinking about what you're writing. You can copy over a whole homework set. Not that you would copy from somebody else, but if you're copying your own, you could do that in about 5 minutes. When you're actually writing math, that's free time. And so take small steps, write a lot, you'll finish your problems a lot faster than if you're sitting there thinking, let me see, -1 minus a -2, so x minus y, and you arrive at a 1, or reliably, I don't know, you might end up with a -1. So writing it out like this gives you that upper leg, also gives you the opportunity to go back, ask that question, did I get my signs right?